Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have an amazing webinar today. I'm very, very excited about this topic. But before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded. So if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use the question and answer tab on your interface and submit your question, and we'll try to get to as many as we can near the end of today's webinar. We also have an interactive chat interface here, and so we encourage you to send us your comments, questions, whatever you want to send over to us. We will welcome it, and we'll chat you right back. We also have at the end of today's webinar drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is persistent storage for the cloud native enterprises with Red Hat OpenShift and StorageOS. Our speaker today is Alex Kirchhoff, who is the founder and CEO of StorageOS. Alex, thank you so much for joining me today. I wanted to make sure I got your last name pronounced correctly. So thanks so much for joining. I appreciate it.
Thank you, Charlene, and thanks for checking out to pronounce my name. A few people
No
get it
problem.
right.
Yeah, well, that's all right. Listen, I know you've got a great presentation on tap. I'm going to go ahead and take myself off camera, put myself on mute, and let you get right to it.
Great stuff. Okay, so as Charlene said, good morning, good afternoon, good evening, depending on where you're joining us from. Today I'll be talking about how we work with storage in cloud-native environments with OpenShift and StorageOS. By way of introductions, my name is Alex Kirchhoff. I'm the founder and CEO of StorageOS, where we're building a software-defined cloud-native storage platform. I also kind of wear 2 hats because for the last couple of years I've been co-chairing the CNCF storage SIG. Working with the community and different vendors on trying to clarify and work on projects for the cloud native storage space. And my background is actually from working in financial services, building and engineering infrastructure platforms in these very large enterprises. So perhaps not the traditional startup founder, but I'm certainly enjoying the adventure of StorageOS. So what is StorageOS? StorageOS is a software-only cloud-native storage platform. We are working with a number of enterprises, allowing them to run their containerized applications in Kubernetes and OpenShift, whether they're running in the cloud or on-prem, or what's more common nowadays is some combination of both in a hybrid cloud. We're working with customers in a number of different verticals, including financial services and service providers, but generally any large organization that's on their Kubernetes journey. And a lot of people ask, well, what's the deal with storage in cloud native? So I'm going to cover a little bit about some of the principles and the journey to cloud native that we see in a lot of enterprises. So as most people are familiar, storage is that foundation layer that provides high availability and performance and scale for enterprise systems and applications. And it's kind of baked into most architectures where, we're trying to balance high availability with scalability and also, performance. And I guess what's changing now is this kind of concept, that we have a saying where we think that we have this belief that cloud is not a place. What enterprises are looking for is this concept of self-service and an on-off consumption model, and the automation around deployments and operational automation. So balancing the availability, scalability, and performance with the self-service and automation is one of the biggest dilemmas in in the storage space. And that kind of got us thinking about how does that translate to cloud native storage? And we put together a few principles, and we sort of thought long and hard about some of this. And these principles kind of form the manifesto for our engineering and our architecture. So the first point is, cloud native storage needs to be application centric. Today, many storage systems are very focused on providing storage to servers and providing storage to operating systems or hypervisor instances. But in the cloud native world, it's the application that's containerized and the application is portable. And fundamentally, there's a core challenge that data needs to be able to follow the application. So in a cloud native world with Kubernetes and OpenShift, we want storage to be able to follow the application and be application centric rather than being server centric. The second point is, most organizations have put quite a lot of effort into containerizing their applications, which mean that their applications are portable and the applications can run in different platforms, whether they're on-prem or in the cloud. And so what you really want is a storage system that's also, preferably software-based and platform agnostic so that it can be consumed in an automated manner in all of these different environments. And finally, sort of very importantly, is the concept that cloud native storage needs to be declarative and composable. So, we have this saying in the cloud native world for a long time where we kind of distinguish between pets and cattle. Pets being, these important animals in your life that you take care of and water and feeds, and cattle are a lot more homogeneous and dealt with in herds, and that's kind of what we're trying to do with cloud native. We want everything to be automated, and for that to be automated, it needs to be composable. So the idea is that we don't want storage pets. We want to be able to power self-service and automation by allowing developers and DevOps teams to be able to compose the requirements for their storage, and for that to happen automatically with the power of Kubernetes and OpenShift. And in fact, we kind of see these three principles coming to life over and over again in enterprises that are taking this journey to cloud native. So most enterprises start with the concept of building their applications in containers, and containers are fantastic because they break that link to an individual server. So all the dependencies and all the libraries and all the security patches that used to be very, very server centric are now application centric, and containers can be applied and deployed just about anywhere. Of course, as soon as your application is portable, it enables it to be orchestrated and automated. And of course, Kubernetes is now that de facto container orchestrator, and Kubernetes does a fantastic job of giving the developer the ability to compose what they need out of their infrastructure. So a developer can now specify things like the compute requirements and the network requirements for their application. And Kubernetes abstracts away the infrastructure and kind of makes that happen on the underlying problem, on the underlying platform, I mean, and automates the deployment and the scaling and the healing of the apps in that environment. But of course, and this is a core point, right? All applications need to store state somewhere, whether it's a database or a message queue or some sort of file system. An application needs to store and retrieve data for it to be useful. And this is where a software-defined cloud-native storage platform like StorageOS with OpenShift comes into play, because it gives developers an end-to-end composable platform. So now a developer doesn't just have the ability to compose compute and networking, but they can also compose storage requirements. So for example, they can define how much storage they need, but also the attributes of the storage, like encryption or compression or replication or other data services. And of course, what this means is that now they can move all of their stateful applications into Kubernetes and OpenShift. And because that environment is effectively templatable and composable, it allows them to build anything as a service. So we have customers coming to this journey, looking to build database as a service or CI/CD as a service, and with new products like the OpenShift virtualization using the KubeVirt project, we also see customers deploying VMs powered by StorageOS volumes and managed by Kubernetes, effectively building an infrastructure as a service. So we talked a little bit about the cloud native principles and the journey to cloud native. So, and what I'm going to talk about next is a little overview of what StorageOS looks like under the covers and how we work in our Kubernetes environments to power these cloud native applications. So StorageOS is deployed and managed, is deployed as a container in your Kubernetes cluster. It doesn't have any kernel dependencies or hardware dependencies, and it has very low overhead. So effectively, it can be deployed anywhere you can deploy a container, which nowadays kind of means anything, anywhere. The operator, the StorageOS operator manages and automates the deployment of the StorageOS container within a cluster. And once we're installed, we virtualize the storage that's available on every node within a cluster, and that can be physical disk in the case of bare metal boxes. It can be virtual disk in the case of VMs. It can be cloud disk if you're running in cloud instances. And we aggregate all of that storage into a pool that spans all of the nodes in the cluster and provides this highly available composable storage for the applications that are running within the stateful applications that are running within Kubernetes and OpenShift. So all of this integration enables Kubernetes to dynamically provision StorageOS volumes on demand. And we also establish a mesh between all of the different nodes such that the StorageOS volume can be instantiated virtually on any nodes within the cluster. And this means that any application that moves, or and that can happen because of rebalancing of workloads, or perhaps because the cluster is being scaled or upgraded, the application maintains a local view of the data and can always continue to access the data that's running on the StorageOS pool. Now, it's important to note that StorageOS is an end-to-end platform and is composed of two main components. We have a control plane that manages the configuration and the overall state of the volumes and the health of the cluster. And we have a data plane that provides the data services that run within the cluster and that power the StorageOS volumes. One key differentiating feature here is disaggregated consensus, and that's a little bit of a mouthful, but it's basically a fancy way of saying that each volume within StorageOS has its own mini brain that powers placement decisions and failover decisions. So effectively, every volume in StorageOS can independently make those placement and failover decisions. And that has two big effects. One, it means that StorageOS volumes, changes to StorageOS volumes happen within milliseconds. So things like failing over a volume or creating or presenting a volume all happen in sub-second time, which enables the high rate of change that cloud native environments and OpenShift environments demand. The second part of this is that this aggregated consensus also powers makes StorageOS extremely resilient to any sort of transient change that might be happening within the cluster. So perhaps a node might be being rebooted or scaled on demand, for example. And the ability for volumes to make independent decisions means that um, only the nodes that are being changed are affected by the overall changes within the cluster. And this allows us to provide deterministic and predictable performance and reliability within the cluster. The second part of StorageOS is our data plane. The data plane provides all of the data services that you'd imagine from a traditional enterprise storage system. And we provide services like synchronous replication to protect data against, say, a node failure or a disk failure. We provide end-to-end encryption for your data both in transit and at rest using keys that are only known to the application. So effectively, you no longer have to hand keys over to a cloud provider or a service provider, for example. And we do all of this with a highly optimized low latency data plane. And I mentioned latency because latency is critical for some of these core production workloads and core mission critical workloads that might be running in OpenShift platforms and StorageOS, like databases or message queues, which actually where low latency directly translates to a higher throughput and a higher transactions per second in these environments. We also have a strong focus on reliability and data integrity, specifically for these mission critical systems. And finally, I just wanted to end this off with, we're very also proud to be incredibly tightly integrated with Red Hat OpenShift, and we're certified and operate within their catalog, which makes it extremely simple and typically, a couple of clicks to get an entire StorageOS system running in an OpenShift system. And I'll cover off a couple of examples and a little run through of how you deploy StorageOS and OpenShift a little later on. So all of this is kind of interesting, and I bet you're asking yourselves, okay, but how does this translate to real life scenarios? So I thought I'd put together a few slides covering off some examples of use cases. I'm not going to be mentioning specific organization names, but all of the organizations, all of the examples here are real life examples from some of the logos that were on our intro page. So the first example is a trading system in a financial services environment, large tier 1 banks. And this is obviously, coming from a financial background. It's one of the things that I'm intimately familiar with, and it's obviously something very close to my heart. In these sort of environments where we have extremely tight dependency on things like message queues and databases, one of the two key things here are the reliability and data integrity and the performance. So we talked about the synchronous replication, and that provides StorageOS in these use cases provides the availability to make sure that data is available across all of the nodes and is accessible anywhere. So that should there be a node failure or an availability zone failure within the environment, the application can be restarted somewhere else. We do this by synchronously replicating the data across different nodes and across different availability zones within cloud environments. And of course, the important thing in these sort of trading platforms, apart from making sure that no transaction is ever lost is, of course, the performance. StorageOS provides this incredibly low latency. We have a we have a performance report which is included as one of the handouts which you can access within the webinar platform. And we're extremely proud to be one of the fastest cloud native systems. And in these cases, we're actually powering trading platforms that run millions of transactions every single day. And then I wanted to mention one last thing. So in many of these environments, what the banks also really need is the ability, when we talk about pets versus cattle, the ability to reproduce an environment and to redeploy something when things go wrong or when things need to be upgraded. So the fact that these organizations can run the same platform in development that they run in production and in acceptance testing environments too, means that they can predictably and reproducibly create the deployments that they need for their applications and debug things when things go wrong, whichever environment they're running in. So we kind of see that the benefits of having that declarative and composable self-service interface extends beyond the ease of use and reducing the total cost of ownership, but it also means that when things go wrong or when dev environments need to be updated, it makes it that much easier to build out these complex financial systems. Another use case is with StorageOS that we have is with managed service providers. And we have a number of different service providers deploying Kubernetes with StorageOS as their storage engine. One thing that we're seeing, I mentioned this earlier, that we kind of believe that cloud is not a place, and what organizations are looking for is the automation and the self-service and the on-off consumption model. And so what we're kind of seeing is this proliferation of different service providers that are providing value-added platforms for their customers. This can be in terms of managed OpenShift and managed Kubernetes platforms for a variety of different verticals. But it can also be with the use of KubeVirts, which can now manage virtual machines. We're also seeing this concept that the managed service providers are building out an infrastructure as a service. So using StorageOS with the power of Kubernetes to manage these more complex environments, and providing the storage that's highly performant and robust and reliable with this shared netting architecture is a fundamentally hard problem to solve. And whilst the compute environment and the network environments are very often commoditized, storage is that's getting that storage engine working with these service providers is a problem that is hard to solve. And we're very happy to be working with a number of these different service providers to build out their platform. We have had a question on the chat, which I'm just going to refer to now, discussing that containers are built with the idea that they are ephemeral or stateless. So the person asking the question was having a hard time understanding how StorageOS actually helps a containerized application with cloud native storage. So the point is, yes, containers can be ephemeral, but all applications have to store state somewhere. And you're either going to store state in a service that you consume, or you're going to store state in a service that you build. Many organizations have requirements to build state in databases or message queues or infrastructure services like Elastic or Kafka, for example, which are not provided by the cloud provider, or perhaps they're building it. They're building partially on-prem and partially in the cloud, and they have the requirements to build out those stateful services. I think, we went through a long time where containers were considered to be stateless, but the reality is every application needs to store state somewhere, and therefore, I think whether you're creating the service or whether you just need a file system to share files between different pods in your application. There's always going to be a requirement for managing a storage engine within a Kubernetes cluster, and this can be in a hyper-converged sense, or it can be to provide data services like additional availability across availability zones, for example. So hopefully that answers that helps with that question, and that's certainly the need that these service providers and the financial services customers that we're working with using OpenShift and StorageOS are looking at. The other thing that the other interesting use case that I'd like to talk about is this concept that cloud native can change and enable different patterns of use within an environment. So one of the things that we've observed quite a bit is that once you give end users and DevOps teams and developers the ability to create things on demand and to create self-service systems, of course they will find new and wonderful things to do with these environments. One of our customers has built a CI/CD as a service where they create on demand tens of thousands of environments, which obviously need tens of thousands of volumes. So every day, tens of thousands of volumes get created and moved and deleted. And so, what we see here is how the power of something like StorageOS with the flexibility of OpenShift and Cloud Native gives the ability to deal with environments where there is a dynamic scale and a high rate of change, which traditional systems just can't deal with. So for example, most systems, even if they do support APIs or integrations with Kubernetes, struggle with that high rate of change. And StorageOS can facilitate these environments and these different workloads because of some of those unique control plane advantages, like disaggregated consensus, which by giving every volume an independent mini brain, it removes serialization and it allows operations to happen in parallel. So even under fairly heavy workloads, things like creating and deleting and moving volumes between nodes is a sub-second operations. And this, I'm highlighting CI/CD as a service, but it does allow and facilitates the use of building anything as a service in these sort of environments. So we've talked a lot about all of these services and running enterprise class storage services within a Kubernetes cluster, and that probably sounds a little complex and overwhelming. But I wanted to show you very quickly what this looks like when you're using OpenShift and StorageOS. So StorageOS is on the Red Hat marketplace and is certified as part of the as an operator within the OpenShift catalog. So effectively, you can, using your OpenShift management console, you can select StorageOS, choose the marketplace entry, which the marketplace is a fantastic facility that allows you to pick. It's a curated list of services, which IBM and Red Hat work on together to create this suite of services for OpenShift. And the StorageOS operator is part of the service, and it's purchasable directly through the operator hub and the OpenShift console. Once you've selected it, you can choose to then install the operator. The operator, like we mentioned, manages the automation and the deployment of StorageOS within the cluster. So you can then create a StorageOS cluster, and 2 or 3 clicks later, you've got a running StorageOS cluster working within your environment, direct from the Red Hat marketplace, and you have the confidence that Red Hat are providing in terms of automated security scans and all of the benefits of that curated marketplace with OpenShift. So, in summary, with StorageOS and OpenShift, you get this orchestrated end-to-end infrastructure platform that powers, that gives you the self-service, but provides those core foundation the core foundation storage services that your important stateful applications need, whether it's the end-to-end encryption and the security, or the replications and the replicas and the HA that give you the ability to make sure that your data is replicated for business continuity and DR purposes, with the performance that you'd expect from a high-end enterprise class storage array, and because we're optimized for the latest NVMe disks, and which are now available for most cloud providers, you can get cutting edge performance with sub 100 microsecond latency in these environments. So effectively, StorageOS with OpenShift allows you to run any application on and build any service on any infrastructure, whether you're building on-premise or in the cloud or in virtual environments. And it effectively allows you to break the hardware and cloud lock-in. So one of the key benefits here is that the same bit of YAML that you'd use to deploy your application with StorageOS on a developer laptop is the same bit of YAML that you'd use to build your dev environment, and it's the same bit of YAML that you'd use to deploy in your prod environments, wherever they are. So effectively, we're making life easier for both the developers and the operators of the platform, reducing the overhead, and providing those standardized deployments, which are so important to some of the use cases that we just discussed. And of course, because you're using commodity hardware and commodity cloud environments, you save those high capex builds related to building out those large enterprise storage physical arrays, and you get the ability to do that using any environment anywhere. So hopefully this has been a good overview to cover off some of the cloud native principles, the journey that we're seeing enterprises take. We also covered off an overview of StorageOS and how it works, and how some of some use cases like financial services and service providers and developer environments are using OpenShift with StorageOS to provide these solutions for cloud native storage. And with that, I'm finishing off my presentation, and we can move to some questions.
All right, great. Well, we do have plenty of time for questions, guys. If you do have a question for Alex, please go ahead and use the question and answer tab on your interface. You can also put it in the chat tab, and we'll be happy to move it over for you. Let's go ahead and dive into the questions that we've received already. Here's one for you, Alex. Does StorageOS support shared file systems or read-write many?
That's a very good question. We get this quite often. So StorageOS natively provides virtual block devices. Effectively, we create virtual HBAs that allow a volume to appear on any node. But of course, some applications need a file system that can be shared across multiple nodes at the same time. So we do that by providing a shared file system service based on NFS. We transparently create the service and the VIPs that can create that shared file service across the different nodes in the cluster. And effectively, then that allows services to access that shared file system wherever they are in the cluster.
All right. All right, great. Here's another question for you. Does StorageOS abstract cloud native file systems like EFS from Amazon?
Yeah, so we virtualize any storage that's visible from the underlying in the underlying Linux operating system. So that can be physical disk, it can be cloud disk like EBS volumes, it can also be file systems from EFS. That said, EBS volumes are probably preferable to EFS volumes from a performance and commercial consideration.
All right, great. Lots of questions have come in, but there's plenty of time, guys. If you do have a question, go ahead and submit it using the question and answer tab or the chat tab. Next question here, does StorageOS, is it compatible with pods running on Windows nodes?
Today, we're very focused on providing the best environment for running OpenShift on Red Hat Linux, of course, and Linux environments in general. We're looking at options to provide the ability to extend the access of those volumes, probably through a CIFS interface with pods that can run on Windows nodes, and that's something that's on the roadmap.
All right, great. All right, next question here. How does StorageOS perform with message queues and databases?
Right. So in many cases, what we find our enterprise customers doing is they're building mission critical applications that do need some core message queues or some core databases, and we find that this is often some of the most valuable systems in the environment. One of the key things here, apart from, of course, the reliability, is the performance for these for message queues and databases, and very often they can be write intensive, and very often they can be serialized. And unlike maybe some other file system type workloads, we see databases and message queues do lots of random reads and writes with very small block sizes. So we've specifically optimized for that type of workload, and we can do that with exceptionally low latency to ensure that we get a high rate of IOPS and a high rate of transactions per second. And again, I think I mentioned it before, but in the handout section, we have a document that covers off some benchmarking and performance of StorageOS in these sort of environments.
All right, let's see. Okay, we have a couple lots of time, but a couple questions here. So if you do have a question, go ahead and get it on in. You can, as I said before, you can either use the question and answer tab, or you can use the chat tab, and we'll be happy to move it over for you. Let's see, here is another question for you here. Can applications and StorageOS coexist on the same nodes?
Right. So it's interesting. We've had StorageOS actually described as kind of like the vSAN for Kubernetes, and in many ways, we see many customers who adopt StorageOS in a hyper-converged topology, where effectively every node in the cluster forms part of the StorageOS pool, and every node in the cluster is also running applications and compute-based workloads. And this gives customers, an incredibly flexible and easy way of getting started with cloud native storage. Another one factor that we do to make this even better for our customers is we have created some additional extensions to Kubernetes to effectively allow for data locality. So wherever possible, we will provide the appropriate scoring and the admission controllers for Kubernetes um, to provide the ability that applications run local to where data is actually stored within a node, and this gives huge, latency benefits. So in general, data locality means that databases run 2 to 3 times faster than if they were accessing data remotely. And especially nowadays with cloud providers providing storage optimized and NVMe type storage as standards, it gives the ability for these applications to run at breakneck speeds in these environments. Um, that said, we also have customers that kind of evolve beyond just plain hyperconverged, and they look to move to environments where perhaps it's hybrid, or perhaps they have a mix of storage specific nodes and compute specific nodes, and we can work with any of those topologies. So it's very much up to the operational and commercial requirements of different customers.
All right. All right, great. I think we have one more question here, but like I said before, plenty of time, guys. If you do have one, go ahead and get it on in. Okay, here's the question. How do you manage storage OS?
Right. So in general, what what we recommend is that StorageOS is tightly integrated with Kubernetes and OpenShift. We use the storage classes and the abstractions like persistent volume claims and persistent volumes within OpenShift and Kubernetes to provide this self-service environment for applications running there. So in general, we expect that most DevOps teams and developers will just consume standard Kubernetes objects like the PVCs, and that translates directly to StorageOS volumes. That said, we realize that some people need more advanced functionality and different ways of visualizing their clusters. So we also provide a set of CLI tools that can provide additional information and perhaps provide additional support tools. And we also provide a GUI service that provides a nice web front end that allows end users to visualize the different nodes and the StorageOS pools and the different volumes that are created, which can be really useful to kind of wrap your head around, where data is within the cluster too.
All right, great. Well, that is all the questions that we have right now. I'm going to go ahead and leave the question and answer tab open for a minute or two to see if we get any more in. While we're waiting, something I neglected to mention at the top of the hour, we have a couple great handouts for the audience. So if you at any time want to go ahead and take a look at what we have for you in the handout section, you can take a look at them, you can download them, keep them for yourself, whatever you want to do, but I highly recommend you check out the handouts that we have in the section. We actually did just get another question in, so why don't we go ahead and do that real quick. Is it fair to say that StorageOS is largely solving a niche use case where you need highly available persistent volumes, but very high I/O rates, almost as your desktop would access a local SSD, which other cloud native storage doesn't provide?
I'd probably, for obvious reasons, argue the fact that StorageOS isn't providing a niche service. Um, you know, Customers using StorageOS with OpenShift are deploying all sorts of workloads from message queues like RabbitMQ and streaming systems like Kafka, um, to analytics like Elasticsearch and observability tools like Prometheus, and of course, databases, whether they're SQL like MySQL and Postgres, and NoSQL databases like Cassandra and Mongo, for example. And we're also seeing, more interesting use cases, more varied use cases, which we never expected to see, quite honestly, with tools like the project from Red Hat with KubeVirt, which actually allows VMs to be managed by Kubernetes too. So I think every application needs to store state somewhere. This is something which is a bit of a mantra for me. Because we kind of have to get over the fact that containers are stateless, because that's kind of anathema to the fact that every application is using a data service of some sort. So whether you're building your database, whether you're building your analytics, whether you're building your data warehousing, whether you're building the infrastructure for an on-prem solution or the infrastructure in the cloud, and you need data services for encryption or replication, for example, you get the ability of building this in a platform agnostic way, in a software only shared netting architecture with StorageOS and OpenShift.
All right, great. Well, I'm going to, again, leave the question and answer tab open to see if we get any other stragglers in. But while we are waiting, just want to remind the audience that today's event is been recorded. So if you missed any or all of the event, or if you just want to watch it again, you will have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, it looks like we are not getting any more questions in, so I do want to thank everybody who did submit questions. There were some really great ones in there, and just a reminder, if you do have a question, I'll leave it there. Go ahead, get it on in. We'll see if we can squeeze it in before the end of the webinar. But right now, why don't we go ahead and do the drawing for the $425 Amazon gift cards? Okay, our first winner today is Colin M. Congratulations, Colin. Our second winner today is Steve W. Congratulations, Steve. Our third winner today is Terrence L. Congratulations, Terrence. And our fourth and final winner today is Ed B. Congratulations, Ed B. We'll be following up with all four of you by email to get your Amazon gift card over to you. So please check your inbox. If you don't see anything there, please check your spam folder. All right, Alex, it doesn't look like we're getting any more questions in, so I'm going to close out today's webinar. Like I said before, I do want to thank everybody who did submit questions. Great questions. And Alex, I want to thank you for such a great presentation. Lots and lots of just very insightful information in today's webinar. So I really do appreciate it. It's always great to hear what's happening in cloud native space in general, but storage is always a big part of the conversation. So thanks again for your time and for your expertise. Really do appreciate it.
Thanks, Charlene. It's been a pleasure to present here.
Excellent. Well, I also want to thank the audience for joining me today. And this is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.